Dear students, myself, Dr. D. Paradesi, Associate Professor of Department of Chemistry, SRM Institute of Science and Technology, Katangalatur. In this lecture, I have to explain about the basic and principal aspects of batteries and fuel cells. So the learning outcomes to the students is to understand the fundamental of battery and fuel cell, to identify the components present in it, explain and understanding the principle behind the batteries and fuel cells and comparison between the batteries and fuel cells, and finally the applications of both batteries and fuel cells. We all know that in our day-to-day life we are using batteries in various forms like mobile phones, laptops, and then even watch, wall clock. Everywhere battery is used. Okay, so we should know the chemistry behind the battery. That is very, very important because we are using battery in everyday life. So battery is an electrochemical device which converts the chemical energy into electrical energy through redox reactions. It consists of one or more electrochemical cells, each containing an anode, that is negative electrode, cathode, that is positive electrode, and an electrolyte. When the battery is connected to an external circuit, electron flow from the anode side to cathode side, producing an electric current. So in overall, the battery can be simply defined as it is a device that stores chemical energy which converts into electrical energy to power the electrical vehicles and electronic devices. So batteries can be broadly classified into two types: primary batteries and secondary batteries. Primary battery is non-rechargeable. So these batteries are designed for single use. Once the stored chemical reactants are consumed, they cannot be used again, cannot be recharged. Okay, so these slides clearly present. I show that. So here, this is the positive terminal. This is the negative terminal. Okay, so this is the zinc, which is chemical energy stored in it. It's a gasket. So the characteristics of this battery is it is a non-rechargeable and a long shelf life and ready to use, and also very less maintenance, suitable for low to medium power applications. So primary batteries have high charge density, therefore it discharges very slowly. It has the high internal resistance. The high internal resistance causes more voltage drop during discharging. As a result, the terminal voltage is less than the EMF of the cell. So there is no fluid inside the cell, so that it is usually termed as a dry cell. So its chemical reaction is irreversible, therefore it cannot be charged again. So it is very cheaper than the secondary cell. Some of the primary batteries are zinc carbon battery, alkaline battery, silver oxide battery, etc. So primary batteries are applied in various devices like a TV remote control, wall clock, flashlight, calculators, smoke detectors, and so on. Now let us move to the secondary batteries. It is a rechargeable one. So it has low charge density. Therefore, it discharges quickly. This secondary cell has low internal resistance. Therefore, it causes less voltage drop during discharging of the cell. As a result, the terminal voltage is almost equal to the cell EMF. It has wet cell and molten salt. Therefore, the periodic maintenance is required. The chemical reaction in secondary cell is reversible, therefore it can be recharged. Therefore, it is also called as rechargeable battery. Secondary cell is it has high energy efficiency and long shelf life, and economical for a repeated use and environmentally friendly. See, look at the setup of secondary battery. This is the anode, this is the anode, and this is the cathode, okay, which is connected to the external circuit. So charge and discharge both are happened. Charging and discharge is happened. So this is the separator, or it's an electrolyte. In presence of the electrolyte, the ions are moved from anode to cathode and cathode to anode, so that the electron flows through the external circuit and produce electricity. So this secondary cell is applied in mobile phone, laptop, EV, electrical vehicles. Nowadays, people are eager to purchase the EV because of the hike in petroleum prices. And UPS, I think, uninterrupted power supply. Here also the secondary battery is used, and renewable energy storage system. Now let us see the basic of electrochemical cell. Okay, so electrochemical cell is nothing but it is a device which converts the same chemical energy to electrical energy. So this is termed as usually galvanic cell or voltaic cell, or electrical energy into chemical energy. This is called electrolytic cell. Through oxidation reduction reactions. Okay, so there are various components involved in the electrochemical cell: anode, cathode, electrolyte, salt bridge, and external circuit. Okay, let us see one by one what are the things happened in these components. So first let us look at the anode. In the next slide I will explain with the images. Anode, oxidation takes place. Always oxidation takes place at the anode. So oxidation is nothing but loss of electron. Then at the area of cathode, electrodes reduction reaction takes place. Okay, so it accepts the electrons. It accepts the electrons. And then electrolyte, it is the medium, ionic medium. It may be solid or liquid. So this ionic medium that allows the movement of ions between the electrodes. So electrolyte, the role of electrolyte is nothing but it separates the cathode and anode, and the transport of ions from anode to cathode or cathode to anode. Salt bridge. Salt bridge, it maintains electrical neutrality. That is migration of ions from one solution to cathode solution to anode solutions. Okay, right. So salt bridge is also termed as separator. And then external circuit provides a path for electron flow from anode to cathode. So this is the way the electron flow from one place to another, so that the electricity will be produced. So this is the working principle of Daniell cell. Look at the same what I have explained in the previous slide. So all the components are here. This is the zinc electrode which is dipped in zinc sulfate solution. This is the anode cell, that is half cell. The another one, copper electrode which is dipped in copper sulfate solution. So this is here, look at, this is the electrode, this is the electrolyte. So here copper is the electrode, copper sulfate is the electrolyte. Okay, right. Now the salt bridge, this is the salt bridge. Okay, now the zinc rod is dipped in zinc sulfate solution, copper rod is dipped in copper sulfate solution, the zinc is anode, copper is cathode. Now the ions are moved from here to there. Okay, transport of ion from anode to cathode. The electron flow from the external circuit to produce electricity. See, simple, if you look at the reaction, zinc loses its electron. This is a zinc rod loses its electron to produce zinc 2 plus electron, 2 electron. Here it is a mistake, it is 2 electron. Okay, zinc 2 plus 2 electron. So these electrons flow through the external circuit to produce electricity. whereas this copper 2 plus accept electron and reduced to form copper solids. Okay, so this is these two off cells are connected to form a full cell. Two half cells are connected to form a full cell. This is called Daniell cell, or we can call it as a primary cell. Okay, right. Now let us see the difference between the primary and secondary batteries with respect to these features. Okay, so primary battery is not rechargeable, whereas secondary battery is rechargeable. And it is a single use, it is multiple use. So the best example is we can use a lithium ion battery, what we are using in our mobile phone. So our mobile phone mostly it contains lithium ion battery. We can charge a number of time and we can use it. Okay, whereas in the primary battery it is one time use. And the cost is low in primary battery, whereas in the secondary battery it is high. Shelf lifetime is long, here it is moderate. Environmental impact, here it is higher waste, here it is lower waste. Simple, very simple, because primary battery is use and throw. Once the battery is lifetime is over, you have to dispose it. Whereas here also secondary battery also, but the lifetime is lengthy when compared to primary battery. So the number of user end will be very high. Say for example 2 years, 3 years we can use a battery, secondary battery. Okay, whereas in the primary battery for simple applications frequently we are changing the battery, so the waste produced are very huge, and thereby the disposal and leads to environmental hazards. Such kind of issues will be there in the usage of primary battery. So a lot of examples are there for primary battery and secondary battery. Now let us move to the important one, what we are using in our day-to-day life mobile phone, which contains a lithium ion battery. So we should know about the basic of how it works. Simply we can say how the lithium ion batteries works and what kind of components are there. Okay, so this battery is a rechargeable and electrochemical energy storage device which stores and releases electrical energy through the movement of lithium ions between the positive and negative electrodes during charging and discharging. So unlike conventional batteries where chemical reactants are consumed, lithium ion batteries by the reversible intercalations of lithium ions into electrodes, allowing them to be recharged hundreds of thousands times. So what are the components involved in this lithium ion battery? Similarly, cathode, anode, electrolyte, separator and current collectors. So the 5 major components are there. Okay. So lithium ion batteries are the cathode involved in the lithium ion batteries are usually made up of lithium metal oxide such as lithium cobalt oxide, lithium iron phosphate or lithium nickel manganese cobalt oxide NMC. The anode are usually made up of graphite, which stores the lithium ions during charging. Electrolyte is nothing but a lithium salt, that is LiPF6, which is dissolved in organic solvent that facilitates the lithium ion transport. A porous polymer membrane that prevents direct contact between the anode and cathode while allowing ion movement. So aluminum foil for the cathode and a copper foil for the anode acts as a current collector. Okay, now let us see the working principle behind what happened during charging. Suppose if you are plugged in for the lithium ion battery in our mobile phone. So the lithium ions move from the cathode to anode through the electrolytes. So electron flow through the external circuit. So electron flow from the external charging circuit to the anode side. So it stores the energy. So energy is stored in the anode side of the battery. During discharge, what happens? Exactly opposite. So lithium ions move back from the anode to the cathode. So electron flow through the external circuit from the anode side. So the battery delivers power. So this is a simple concept and principle behind the lithium ion battery. Okay, what are the advantages? Simply we can say that lithium ion battery, we know that it is lightweight and high energy density than the other rechargeable batteries, and the rate of charge loss is less, and it has a greater number of charge and discharge cycles, and need not be discharged completely because of the absence of memory effects. It operates at higher voltage than other rechargeable batteries, approximately 3.7 volts. Whereas, however, it has some disadvantages correspondingly, like it involves risk of bursting. Suppose if you are overcharging, there is a possibility of bursting, and it is costly when compared to primary cell, and complete discharge damage the battery life, and extremely sensitive to high temperature. It degrades very quickly if exposed to heat, and very short lifespan, 2 to 3 years from the date of manufacturing, even if it is not used in the regular use. Okay, so these are all the advantages and disadvantages. Now the applications, I think all of you know that it is very familiar product. So it is widely used in smartphone and tablets, laptop, EV, electric vehicles, and hybrid electric vehicles, power banks. Nowadays people are carrying always power bank their journey, and cordless power tool, drones, medical devices, and renewable energy system, and aerospace and defense applications. Okay, so now let us move to the another counterpart, that is fuel cell. It is exactly opposite to fuel cell, because battery, the chemical energy is stored, which is released to the uh, electrical energy. Okay, so once the chemical energy is over, then it will not work. Whereas in this another kind of system, fuel cell, here you can supply the chemical energy. As long as you are supplying the chemical energy, it will be converted into the electrical energy. So you can generate the electricity continuously without any interruption. So fuel cell is a device which converts the chemical energy into electrical energy with high efficiency and almost zero emission of pollutant. That is very, very important. So that people are nowadays moving towards a fuel cell. So the first principle of fuel cell was discovered by Sir William Robert Grew in the year 1839. So this technology is used in space studies. In India, it is Gemini and Apollo space studies. Scientists used fuel cell PEMFC for generating electricity. And in space, another important thing I want to share. For space study, those who are in the space program, the person involved in the space program, it is very difficult to carry the water and all basic requirements. So while carrying this fuel cell, the byproduct of fuel cell is pure water. So they can drink, they can consume the byproduct. So they can get the electricity, at the same time they can get the water. So no other harmful emissions from the fuel cell. That's why it is a very important one for producing electricity. Okay, so why we need fuel cell? Just I have explained, since because we people are facing energy related issues. So the alternative one which is very suitable for the energy production is fuel cell. I have already explained these things. Okay, now I'll skip. Yeah, so the basic principle behind the fuel cell is, just look at here, anode. I will explain. This is anode, this is anode, this is cathode. Okay, at the anode, oxidation takes place. That means if you are passing hydrogen gas, if you are passing hydrogen gas, H2, if you are passing hydrogen gas, okay, so in presence of a catalyst, a platinum catalyst, this hydrogen gas is split into H plus and water. See, look at the reaction at the anode. Hydrogen gas is split into H plus electron. So this electron flows through this electron. So look at this electron flows through the external circuit to produce electricity. Okay, whereas the H plus ion pass through the membrane. This is called membrane. This is proton exchange membrane. So the blue color indicates proton exchange membrane, or we can say polymer electrolyte membrane. So it carries the H plus ions and move towards the cathode side. Whereas here in the cathode side you are passing oxygen. You are passing oxygen. So this oxygen combines with H plus to produce water as a byproduct. So this is the simple mechanism behind the fuel cell. So anode reaction, cathode reaction, and the overall reaction H2 plus O2 gives water and release electrical energy. Okay, right. Now let us move to the next one. Yeah, in conventional energy conversion system, the chemical energy is first converted into heat energy, and then kinetic energy, and then electrical energy. Whereas in case of fuel cell, the chemical energy is directly converted into electrical energy without any intermediate steps. That's why fuel cell is considered as a most feasible system compared to others. Okay, so the components I have already explained, anode, cathode, electrolyte. Once again, further refining that the anode is the negative side of the fuel cell where the fuel enters, that is hydrogen. Cathode, it is the positive side of the electrode where oxygen enters. So electrolyte, that is nothing but a polymer electrolyte membrane or proton exchange membrane which separates the cathode and anode, and external circuit where the electron flows and produce electricity. So this is the basic component and principle behind the fuel cell. Okay, how it works, this is also I have explained the same thing, whatever the explanation I have given with the slides. Okay, so based on the electrolyte employed, fuel cells are classified into various types like solid oxide fuel cell SOFC, molten carbonate fuel cell MCFC, phosphoric acid fuel cell PAFC, alkaline fuel cell AFC, and polymer electrolyte membrane fuel cell PEMFC, direct methanol fuel cell DMFC. On what basis it is classified? Based on the electrolytes. So in the first case, solid oxide, yttrium stabilized zirconia, that is the electrolyte, solid oxide, and molten carbonate, potassium chromate and lithium carbonate. So this is the molten carbonate. Whereas if we are using concentrated phosphoric acid, then it is phosphoric acid fuel cell. Alkaline fuel cell, we know that potassium hydroxide. And PEMFC, this is one of the important thing. For PEMFC, proton exchange membrane or polymer electrolyte membrane, here people are using perfluorosulfonic acid membrane, that is nothing but Nafion. So that is the state of art material for this PEMFC, perfluorosulfonic acid membrane. Here people are using a thin film, that is polymer film is used as an electrolyte. Okay. Whereas in DMFC also the same kind of polymer film we can use. So the operating temperature of these kind of fuel cells are around SOFC and molten carbonate. The first two fuel cells can be operated at very high temperature, around 600 to 1000 degrees Celsius. We can operate SOFC and MCFC. So it is applied in vehicular auxiliary power, electric utility, stationary power. So various applications we have. Whereas in this phosphoric acid and alkaline fuel cell, moderate operating temperature 100 to 150, 250 degrees Celsius. So it is used in military and space vehicles. Whereas the moderate operating temperature, room temperature to 150, this PEMFC and DMFC. PEMFC and DMFC, room temperature to 150 degrees Celsius. Here the charge carrier is a proton and the efficiency is comparatively high, so that people are doing research in the area of MFC and DMFC a lot. Okay, as I said already, the electrolyte, based on the electrolyte only, fuel cells are classified. Now, in the electrolyte is usually considered as the heart of the fuel cell, because the role of electrolyte is very important. So these electrolytes can be further classified into various categories, like perfluorinated, partially fluorinated, non-fluorinated, and hybrid membrane. So among the four categories, now this perfluorinated, that is called Nafion membrane, PFSA membrane. This is widely used and commercially available. Commercially available. Okay, partially fluorinated. Now there are number of Flammia, Axion, so many membranes are available for the partially fluorinated. Since the formation of carbon fluorine backbone is very difficult to achieve and highly complicated synthetic procedure for the carbon fluorine backbone, people are trying to find alternative electrolyte based on the non-fluorinated and hybrid polymers. So non-fluorinated, it may be fully carbon or carbon hydrophobic, incorporated with some hydrophilic additives. So these are all the areas people are focusing on their research work. Okay, now as I said already, the Nafion is the state of art material. So this image, this is nothing but Nafion image. It's a thin film. Okay, so the structure of Nafion is displayed here. It is fully carbon fluorine backbone, and there are three different segments in the Nafion structure. One is carbon fluorine backbone and perfluoroside chain along with the sulfonic acid functional group. So carbon fluorine backbone, perfluoroside chain, and which is attached with a sulfonic acid hydrophilic segment. So because of this structural arrangements, it has a lot of advantages. It delivers high power density and low weight and volume, used for transportation and stationary applications, and it produces a lot of proton conductivity, and it is highly thermally stable. So the thermal stability, conductivity, mechanical stability, everything is in a good range of operating conditions. So that Nafion is the state-of-art material for the PEMFC. However, it has some drawbacks. At the elevated temperature, there is a drop in conductivity. So this uh, drawback suggests initiate researchers to find out the alternative membranes for Nafion. Okay. But still people are using Nafion. But there are another drawback is highly complicated synthetic procedure for the carbon fluorine backbone. So it is not an environmental friendly manufacturing procedure. So these are all the things induce researchers to find the alternative one. Okay, so these are all the components involved in the fuel cell. As I said already, the same thing, anode, cathode, everything. It is viewed in a separate view, and a graphitic plate, a carbon current collector, and ME assembly. This is very important. Proton exchange membrane. This is nothing but MEA assembly, membrane electrode assembly. So the once MEA is assembled, it will be connected with various gasket and graphite plate and the current collector. It should be attached with the anode and cathode, merged, and the whole setup is called a single cell. The whole setup, that is graphite plate, gas diffusion layer, catalyst, MEA assembly, and another hardwares, gasket and current collector. So collectively we can term as a single cell. Then you have to prepare number of single cell. This is one single cell. Then the number of single cells you have to prepare individually and connected in a series. That is called stack. Fuel cell stack. Okay, right. Now the single cell, how it is working. So based on the commercialization benchmark of PMFC, the people are the researchers are targeting the cost reduction for the PEM fuel cell. It is less than $30 per kilowatt for automotive applications, and the power density to improve the efficiency. Automotive application, the PMFC is greater than 1 kilowatt per liter, and they aim to produce such kind of enhanced performance. And hydrogen infrastructure, that is the biggest challenge for commercializing EV and other similar kind of devices, because storage of hydrogen, that is highly risk. People are thinking that. So the hydrogen fueled power stations are very less in marketing. So this kind of drawback restrict the commercialization of those things. So based on the applications oriented, actually in Korea and Japan and US, many countries, they have already commercialized fuel cell vehicles. Okay, a lot of fuel cell vehicles are there, like even hydrogen fuel cell aeroplane and BMW car and hydrogen rail nowadays. In India, recently in India, they have signed a big project, that is RDSO. That is a research, design and standard organization which developed a hydrogen rail, which is soon it will be commercialized. So a lot of applications we have. So not only limited to this kind of big application, even small applications like fuel cell bicycle, small boat. Okay, so many kind of small devices can be operated. Even toys, we can construct a small device with the help of a fuel cell. So there are a lot of applications. Future it will be commercialized, because nowadays many researchers, they are working behind the design and development of PMFC, like membrane, catalyst, and wherever the possibility to reduce the costs. So in those areas, researchers are doing their effort to commercialize. So very recently we have EVs are very familiar. So soon it will be converted into fuel cell vehicles. Nowadays many places it is slowly implemented, but in future definitely a lot of fuel cell vehicle will run on our roadsides. Okay, so this I will complete my lecture. So any queries, just raise your comment, I will answer it. And hope you understand the concept, the basic principle behind the batteries and fuel cells, and the difference between those and applications of batteries and fuel cells. Okay, thank you so much for your listening and patience. Once again, thank you.